Namastey Coders, I hope you are fine, doing well in your life. So today we are gonna solve the problem of the day for 15th February. So this problem is actually very interesting. So, but I have solved this problem in a oven time complexity. So let's see how can we solve this problem in a oven time complexity. So the problem is find the punishment number of an integer, right? This is a medium type of problem. Topics are maths and backtracing. Okay. So given a positive integer n, return the punishment number of n, right? The punishment number of n defines as the sum of square of all the integer I such that first of all I belongs to 1 से लेके n, both inclusive. Then the decimal representation of I into I can be partitionized into contiguous substrings such that the sum of the integer value of these substrings is equals to I. What is this? Let me explain you with an example. Okay, so let's take the example of 37. Actually I have solved this problem, so I will explain you well. So with example 37, what we need all the i's from 1 से लेके n minus 1 से लेके n both inclusive, and we're gonna sum we're gonna we have to return the sum of all the squares of such i's, right, which has these properties. So let's discuss what these properties actually are. So as so according to our rule, this channel's rule, we will solve the problem, any problem, in a specific manner, right? So the specific manner is, first we will discuss all the details of the problem. Then after discussing the details include the what is given and what is expected, or other and the other details. After detail we will gonna try to solve the problem in a native approach, right? Then we will try to solve the problem in optimized approach. So this is the standard method to solve any problem in an interview also, right? So this will gonna help in your interviews. So let's start with the details. So we have discussed the details, right? So this is given. Let me explain to you well, right? So with an example, n is equals to 37. So we have to find I which belongs to 1 से लेके n both inclusive, and the second property of I is I into I, right, can be partitionized into contiguous substring such that the sum of the integer value of these substrings equals to I. So let's take the example of 9, right? So 9 will represent 9 into 9 is nothing but 81, and 81 can be represented as 8 plus 1, right? So this is 8 plus 1, so can be partitionized into contiguous substrings. So we have partitionized 81 into 8 plus 1, and the sum is 9, such that the sum of the integer value of these substrings is equals to 9. So that is, so 9 can be taken, right? So I can become 9, I can become 1 also, because 1 has a square 1, and we can so since 1 into 1 is equals to 1, right? So we can make a substring sum is equals to 1, right? Other than 1 and 9, we can like we can choose I as 10, right? So 10 square is nothing but 100, and 100 can be represented at 10 plus 1, 10 plus 0, which is again 10. So yeah, we can take, so I can be like 1, 9, 10. I can also be a 36, right? So as you can see, 36 into 36 is equals to 1296, right? And which can be represented as 1 plus 29 plus 6, which is 36. So we can choose 36 also. So similarly we can choose all these numbers, right, from 1 से लेके 1000, right? So because this is the constraints, so n can belongs to 1 to 1000, right? So we have to find all the integers I which belongs to such properties. So we have pre-computed that. So that is the most optimized approach, but we will discuss the native approach also, right? So this is given, right? Then we have to find all such i's, square of all such i's which belongs to 1 से लेके n, right? So for 1 से लेके 10 we have 1, 9 and 10, so the square is 181 and 100, so the answer is 182, right? Similarly for 37 we have 36, so we have 1, 9, 10, 36, so answer is 1, 4, 8, 2, 7, 8. So this is how we are gonna solve this problem. So that is all we need to do in this problem. So let's discuss the native approach, right? So native. So first of all, we need to find the partition, right? So if let's say we have 10, so we know that 10 square of 10 is nothing but 100. So we need to make a function which can find that if 100 is the possible I or not, or I can say 10 is a possible I or not, right? So let's make a function check number which will give I. So what we will do, first of all we will find I into I, then we will find that we will find that that number can be partitionized such that number can be partitionized such that this property get solved. So what we'll do, we will try to partitionalize this number, right? So let's say we have 36 into 36, which is 1296. So first of all, and we need the total sum to be 36, right? So we will pass two integers in this number. So we'll pass I and k, let's say, right? So we will need to partitionalize I such that the sum will become k. So what we'll do, we will make I as 1 to 9, right? We'll remove 6. Okay, so we will remove 6, of course. Now what we'll do, we take this 6, right? And we can say that if we are making 6, right? We are removing 6, we can subtract it from 36 because we need now only 13, because we are just we have to add all those numbers now. So we will subtract it from 36. So we'll pass 30 now. So we have 126 and 30, 129 and 30, right? Along with this, what we'll do, we'll make two partitions, 12 and 96. 12 and 96. So we'll pass 12 and we'll subtract this partition, right? This the sum of this partition from 36, right? So the sum will become 15. So 12 minus 15, 36 minus 15 is nothing but 21. And we'll do 1 comma 296. So the sum of 296 is 17, I guess. Yeah, so 13 minus 17 is nothing but 19. So we have now 3 partitions, right? So this is 1 comma 19 remains, right? So now we will check with this that 129 comma 30 is possible. So we will remove 9. So there will be remain 12 comma 21. So this is not possible because 12 is smaller than 21. This is also, these cases are also not possible because these initial numbers are smaller than this. So we will also ignore these cases in the base cases only. So we have 129 comma 30. We will remove 12 comma 21. Now we will remove this 29, right? We will partialize this 29. So we will remain 1 comma 1 only, and 1 comma 1 will answer 1. So if any of this answer will give 1, so we can say, yeah, we can partialize this string. So this is what we need to do to check the partialized string, right? And then if we check this partialized string, what we'll do, we will check for every I possible, right? So this is what is the native approach, right? So that can be done in nothing but O and time complexity, which is very good, because we have to just find the I from 1 से लेके n. Okay, and this parsonized can be done in 3 iterations only, 3 to 4 iterations, right? So the overall time complexity will become On. I hope you understand this native approach. Now in the most optimized approach, or this approach, what we'll do, there is very small constraint, right? 1 से लेके 1000, so there are only limited numbers, so we will pre-compute those numbers using this parsonized technique in another in, let's say, our local machine, and we'll pre-compute all the numbers from 1 से लेके 1000, and then we can use those numbers. We don't need to like check parsonized string again and again. Like what we'll do, we'll iterate over this array from the starting till given n, and we will add this square of those number in the result, and we will return result. This is all we need to do. So this is done in O1 time complexity. The overall time complexity of this is O1, and we have solved this problem in 100% beat. So that's all, guys, from my side in this video, in this solution. I hope you understand this problem well, as well as the solution. If you find this video helpful, you can share your thoughts in the comment section, as well as I have created a WhatsApp group where we can discuss multiple things, including the doubts about projects. We can start a project, we can do some freelance work there, so I suggest you to join that channel using the link given in the description box. Along with this LeetCode problem of the day series, we have also started the LeetCode 75 series, in which we will solve all the most important 75 questions from LeetCode. There is a sheet called LeetCode 75, so we will solve all these problems. We have already solved the first problem of every topic in the playlist, so you can check those problems as well. We will start with the second problem. So we have solved this problem. Now we will wanna solve the problem of sliding window in next video. So stay tuned with me. Subscribe me if you want more videos like this, right? So thank you for your time. Thank you.